Good afternoon, students. Let's start with the combination of capacitors. As we have already studied about basics of capacitor, now we will read about the combination of capacitors. Earlier in the 10th class, we have studied about the combination of resistors. Here we will do the combination of capacitor. This diagram is a little messy. Let me make it here clearly for explanation. So this is the series combination when one capacitor is connected directly to the other by from one end only. Only one end of these capacitors are joined together. So this is its series combination. Now for a general expression we have three capacitors. The number of capacitor can be any, but for generalization, for general expression, we have taken three capacitors, C1, C2, having capacitance C1, C2 and C3, because the capacitors are joined one after another, so the potential difference across each capacitor is different. The total capacitor across three capacitors is V, and along each capacitor the potential difference is different because their both ends are not joined to the similar points. Their both ends are joined to the different points, so the potential across each capacitor is different, that is C1, C2, C3. And because we are taking series combination, so here the charge on each capacitor will be same. One plate will be having positive Q and the other plate will be having negative Q. Plus Q, minus Q, plus Q, minus Q, and Q will remain Q same, and potential difference different. So according to the formula, as we know, potential difference across a capacitor is charge stored divided by the capacitance of the capacitor. So V1 is equal to Q upon C1, V2 is equal to Q upon C2, and V3 is equal to Q upon C3. Now we know that the total potential across each along all the capacitor will be the sum of potential difference across each capacitor, that is V is equal to V1 plus V2 plus V3. Now from here we will put the value of V1, V2, V3 that we have put here. Now this is the total charge on these three capacitors, and this is the total capacitance of these capacitors. Let me write it CT. So Q is same in each case, so we have taken Q common. We are left with 1 upon C1, 1 upon C2 plus 1 upon C3. Q is same, so it is cancelled out, and we are left with 1 upon C is equal to 1 upon C1 plus 1 upon C2 is equal to 1 upon C3. This expression is opposite to that of in case of resistors, because in this expression, if we would have done this for resistors in series, this expression would have R is equal to R1 plus R2 plus R3, but here the expression is opposite to that of resistor. The total resistance when capacitors are joined together in series will be 1 upon C1 plus 1 upon C2 is equal to 1 plus 1 upon C3. So this is the combination of capacitor, and this is the general expression. Whenever we have capacitor joined in series, the total capacitance will be calculated by using this formula. Now the parallel combination. In parallel combination, ends of capacitor are joined to the same ends, so the potential across each capacitor will be same, that is V along each, but the charge will be different in each case. For first it is Q1, for second it is Q2, for third it is Q3. So here, as we have V same and Q different in each case, so Q1 is equal to, from the same formula, V is equal to Q upon C, Q is equal to CV, so C1V, C2V and C3V, because we have three different capacitors and their capacitance will be C1, C2 and C3, and V along each capacitor is same, and Q1, Q2, Q3 charge accumulated by each capacitor or stored by each capacitor. So here total charge will be Q1 plus Q2 plus Q3. Put the formula, V is same, so cancel out, and the total capacitance when capacitors are joined in parallel will be C1 plus C2 plus C3. So from these two cases we can see that when capacitors are joined in parallel, their capacitance will gradually increase because it is directly adding, and here their capacitance will reduce. So this is the combination of resistor, series combination as well as parallel combination. Now energy stored in a capacitor. As we are storing charge in a capacitor, obviously charges will be stored in a form of energy. How much energy is saved in that particular capacitor, on the amount of energy that it can store. As we know, we will start with the potential. We know as potential is work done per unit charge. So if we want to find the energy, we know that work and energy are interrelated terms. So here we will find energy using work done because they are similar terms. So work done will be V dq. From the formula V is equal to Q upon C, here V is equal to Q upon C dq. Okay, this is the small work done by potential to store the charge, but total work done of gathering charge capital Q on a capacitor, the work done will be 0 to Q because we want to charge a capacitor from neutral to Q value. So it will be Q upon C dq. Now 1 upon C will be left out because it is a constant value for every capacitor. So Q dq, the answer will, the integration of this will be Q square upon T 0 to Q. So the we will put upper limit minus lower limit. Upper limit is Q square by 2 and lower limit will be 0. So we are the work done will be Q square upon 2C. As we know Q is equal to Cv, so put the value here. W is equal to C square V square upon 2C. Cc cancel out, so we are left with 1 upon 2 Cv square, and this can be written as half CVV. So V is Q upon C, so C cancel, we are left with 1 half QV. So three expressions can be there for work done, and these work done can be written as energy. So U is equal to Q square upon 2C or half CV square or half QV. So this energy is stored in a capacitor while it store a charge. This much energy is stored in the capacitor. So this is your expression for energy stored in a capacitor. You can give your doubts in the comment section, or you can ask your doubts there. Now for homework there will be two questions. First, I have already told you the series combination formula and the parallel combination formula. So here we have a circuit. Here each capacitor is of 2 Faraday. So from this diagram we can see that all these three are in parallel. First of all, solve this parallel combination. Let's say Cp. Then C1, Cp and C5 are in series. So if, first of all you will apply parallel combination formula here, and then for these three combination you will directly apply the formula of series combination, and then you can find the equivalent capacitance of this particular circuit. Write result of this question in the comment section. Write its result in the comment section. The second question is, you have to obtain the equivalent capacitance of the network shown here. Again here you have these two are in series. Okay, so let's say CS, and then C1, CS and C4 are in parallel. So in this way you will find the equivalent capacitance, and you have to also find the charge and the voltage across each capacitor. If you have any doubt you can write in the comment section, and if you can solve it, otherwise I'll, before starting tomorrow, I'll first describe